Now that we're ready with our simulation, it is time to add some geometry to our particles and get ready to render. So remember, we currently have some color. We added color to the particles based on the texture on the terrain. But just as an extra tip, if you don't really need the projected texture or a particular image in your particles, you can always use a noise or some procedural color for the rendered material. So thinking ahead, what I'm going to do is I'm going to add a rest position node just before the simulation, and then I will proceed to cache the particles to instance some geometry and render. So let's add a rest position. Remember, connected before the simulation is generated. That's all we need to do. And now for exporting the particles, I'm going to add a .io node. So what I want to import into this node is, of course, the .grains network. So with the .io node selected, you can drag and drop this network here under the .network parameter. On the .node, we can copy the name of this network and then type slash. And after the slash, we can type velum. And what we want to bring in is the velum object one. So double click on that object. And as a reminder, if you go into the network, this velum object node is what contains the particles. So this is what we're bringing into the .io node. So let's go back, select our .io, and here we will have a preset to bring in particles. So under presets, choose particles. And that is all we need. If you press play, you'll see the same result that you had here under the simulation. So let's stop this now. Let's now add a ROP geometry as usual. This ROP geometry output will allow us to save the particles. So just make sure to select render frame range. And actually, just before we do that, I will increase the frame range to 60 frames. And what I usually do is I save the particles on the geo folder and under the name of this node. So let's name this node Sand Explosion. So I will delete the heap name variable, and instead I'm going to use the OS variable. Then type slash. So remember, the OS variable is the name of this node. And then the file will also have this name, Sand Explosion. The frame number, you can give it a padding, for example 4, and with a .bgo extension. So the bgo.cs is Houdini's native extension. So let's cache the particles. Click Save to Disk. And I will be back in a few minutes. Okay, so now that we've cached the file, we can add a file node to load the file back. I usually color it blue. And what we can do now is channel reference this output file. So you can right click, copy parameter, and paste it to the geometry file on the file node. So right click on the parameter and paste relative references. And here we are reading the actual cache. Okay, so real quick thing, just before we continue, you may have noticed this small bump in the first few frames. And what's happening here is that the particles are still settling just before the rock hits them. So what we can do just before the file, or actually just after the file node, we can add a time warp node connected to the file. And here we will have the option to start reading the file or the input geometry from a specific frame. We can make the input frame start at frame 6. Same for the output frame range. It should start at frame 6. Otherwise, we would change the speed of the simulation. So we don't want to warp the time. We just want to make it start a few frames after. So the pre-hold option is fine because just before we get to frame 6, this frame will be repeated and will look static. So now we got rid of this pop and we can continue. So now let's add a noise color for the particles. For that, we will add a point up. Connected here under the time warp in the first input. Let's call this add color. I will also change the color of the node. Now we can dive into the VOP node. And what I'm going to do is bind in the rest attribute that we created. So type tab, then bind. And in this bind node, here we will be expecting a parameter. So that parameter is called rest, and it is a vector. So remember, the rest attribute is based on the particle's position on the first frame of the simulation. And we will use this position to sample the noise. So add a turbulent noise. Connect the position of this noise to the rest position, and then the output of the turbulent noise to the color attribute. And now we're starting to see a pattern. We may want to increase the frequency. And now we can add a ramp parameter node to remap these colors. So if we go back to our SOP context, here I will have my ramp. And you can change the color to whatever you like. So for now, I'm going to look for some sand color. I will let you tweak this to whatever colors you want. So this is just an example. In the end, you could use a projected texture we originally did, or add your own noise pattern. Another thing that I usually do is promote the noise parameters so I can change them from the SOP level. So I usually promote the frequency, the offset, and maybe even the roughness. So if you go back to SOP, you'll have all these parameters here. Okay, so I won't spend much time on the color. What I want to do is continue to add my p-scale attribute with a point wrangler. So remember, we always need the p-scale attribute if we want to instance geometry. So I will name this node add p-scale. And what I want to do is randomize a bit the particle scale. And we've done this before. So let's type on our expression f, because the p-scale attribute is a float. Then type at p-scale equals rand, open parentheses, and we will use the ID attribute of the particles. So we can close parentheses and type semicolon. So as we know, this will yield a value between 0 and 1. And now I'm going to fit these values to a minimum and maximum value that the user can choose. So I'm going to use the fit01 function. So type fit01, open parentheses, and I will fit the resulting value of the random function between a channel that the user can change called min scale and another channel called max scale. And don't forget 2 close quotes. So again, I'll go through the script real quick. We're randomizing the value per particle. Then we're fitting this value within 2 channel values. Now remember, the channel function only has a name, and it can be between single or double quotes. So you can do single quote or double quote, and it will work the same. And once we have these channels defined, we can click on this button to the right to create the actual interface for these values. So for now, let's go with 0.01 and 0.05. Now let's add a box. So we will copy or instance boxes to these particles. Then I will add a copy to points node. Connect the box in the first input and the points on the second input and make it active. So here we have our boxes, the actual sand geometry. Of course, they are huge, but since we created some channels here, it will be very easy to change. I will just add a few zeros. And depending on how close you are from the particles or how many grains you have, you may want to continue tweaking this scale. So let's go and see through the camera. Let's pick a nice frame. And with the motion blur and the movement of the particles, I think these values are fine. So now let's add another null. Let's call this null out and change its color to black. So I think we're ready to render. You can save your file and go to the render view. So since we already have a camera, it's called camera 1. You can select it here from the list. We only need to create a mantra node. So go to the render menu. Under create render node, mantra PBR or physically based rendering. And let's call this mantra node sand explosion. So just make sure you have the correct camera, which in this case is fine. Select render frame range and make sure to specify the name and the folder of the files. So by default, they will be on the render file. What I usually like to create is a folder with the OS variable. So type $OS, then slash, and then the files will also have the name of the node, sand explosion, and as usual, the frame number and the EXR extension. And I think we're ready to render. You may want to check under rendering the pixel samples. So for testing, 3 samples is fine. Usually for final renders, I can go up to 6 or 8 samples, but this depends much on your scene. So let's render a single frame and let's see what we get. Okay, so this is what we have so far. A few things we need to do. First of all, we have no lights. Another thing that you need to note is that we still have the original colors coming from the textured material. So let's start by creating a material. Go to the material context, create a classic material or a classic shader, and let's call this noise material. And by default, the diffuse color will use a point color from the geometry, which is fine. Just make sure to change the base color to white. One other thing that I will do is under the reflection base, I will increase the roughness rather high, say to 0.7, and decrease the intensity to 0.2 or 0.25. So let's go back to the object context, assign this new material to the node. So it's called noise material. So this is looking much better. Now we can see the noise color that we added. Another thing that I want to do is, for now, let's show the terrain. And now let's add some lights. So you can control click on the environment light to add one light. Here what we usually do in production is add an HDRI or something similar. In this case I will just decrease the intensity, say to 0.2, and add a new distant light. So I can control click on the distant light to create a new distant light object. Then I will click on the lock camera so I can orbit around my scene interactively. And angle the light so we have more interesting shadows. So make sure that once you finish positioning the light, turn off the lock camera. Go back to your camera view. Okay, so let's go back to our render view. The distant light may be too strong now. I will reduce the intensity to say 0.6. One other thing I'm going to do is change the type to sun, just so we can have softer shadows. So this is looking much better. Now under our out context, on the mantra node, let's make sure to turn on allow motion blur. So you may not see any change here. We need to make sure under the object context that our mortar explosion has the velocity blur turned on, and this you can find under the sampling tab, geometry velocity blur. By default it is off, so we need to turn this on and pick velocity blur. So this is looking nice. Of course, there are still many things that we can do. For example, we could add some trails, but we already know how to do this. We could also add some nicer materials, and of course we could add some volumetrics, and we will do that in next volume of the Total Destruction course. So for now, I hope this has been useful for you, and hopefully you can continue to practice and continue to learn this wonderful program called Houdini. So I will say bye for now, and I will hopefully see you in next tutorials.